There are a lot of companies out there that have SLAs that quite literally pay their customers for every second of downtime that they have. Had customers who were like, yeah, we had an incident that cost the company $10 million. When I say releasing product, there's nuance to that. Sometimes the product is literally put this text file in your cursor rules. Boring as shit, like log4j. Again, the principal software engineer would look at that and be like, this is bad. No. And like he would probably get mad at me. We're spending less time in the code writing part. Great, fantastic. That doesn't automatically make everything else faster or better. My name is Phillip Carter, as I'm sure you've surmised. So I currently work for Honeycomb, which is an observability company. Observability meaning you have your code is instrumented to emit data at runtime that tells you about what's actually happening when your users are pounding this particular service in a particular way. We kind of are a little bit different from the Datadogs, Dynatraces of the world, in that we try to emphasize capturing good data in the first place rather than just having a bunch of slop logs that kind of don't really tell you a whole lot. And anyways, there's a whole observability. Anyways, I've been working for them for about 3.5 years or so, and been heavily involved in the Open Telemetry project, which I'm a maintainer of, trying to help like standardize how systems and applications can describe what is happening to them at runtime in some deployed environment, so that you can have useful information telling you that, 1 million users just hit this endpoint, and like, what did that actually do? And is that something you should be concerned about? That sort of stuff. But building it out as an open standard so that people, instead of tying themselves to things like a Datadog agent or something that sort of locks you into a particular product and ultimately a very large bill at the very end, you actually own the creation and processing of that data sort of at any point of the pipeline all the way up until analysis. And then, you can sort of pick whatever tool works actually best for what you're trying to accomplish and what's the right setup for your team, as opposed to being locked into a big company saying that you should be looking at graphs a particular way. So we kind of serve like the SRE ops market right now, but observability has started to poke into the developer spaces, especially as teams are getting into like service ownership. And a lot of software developers who may not have had to look at production logs a whole lot before in the past are like, well, this is now my responsibility. And so that brings along a lot of opportunity, we think, to help sort of like reshape what observability means for this audience in particular. Prior to that, I was at Microsoft for about 6 years working on the .NET team. I was the PM for the F# programming language and its tools for 5 of those years, and had just a lot of work done in like IDE tooling, compilers, programming language design, sort of that weird, funny, fuzzy space of like, how do you make something that is a tool that people use, but that they actually want to use, and sort of straddling the line between like, the hard science of like compiler engineering work and the arts and crafts of like, does this make a good feature in a programming language, which is very fun. And recently meaning about September of 2022, I had gotten bit by the AI bug pretty hard. This is right before ChatGPT came out, but prior to that, I was using GitHub Copilot on like one of the super early access licenses they had for quite a while. And I sort of saw this opportunity where I was like, okay, well, I think software development is going to change forever with this kind of stuff. It's really just a question of in what direction it changes. But if you have a machine that can output text that happens to be code, and you can direct it in all kinds of interesting ways, that just reshapes what software development is going to be. I immediately saw that, and I'm like, okay, well, in the domain of software, you say you want to accomplish X. You can have a machine that can output code that does a thing. That doesn't necessarily mean the code is going to do exactly what you want, but it's some approximation of what you want. And it's sort of this game that you have to play of like, how probabilistic are the outcomes that I want, and how specific do I have to get to sort of get the thing that I want from this machine. I saw a similar parallel in the observability space, because in the observability space, you might get like a Slack alert saying that something is going on with this service that you're an owner of, so you should go take a look. there's a million different ways you can interrogate about what's going on. Like, you see a latency spike and it's like significant. It's like, okay, well, why did that happen? And there's a million potential reasons why it did that, and there's not necessarily one correct way to go down this path where you have these hypotheses where you want to ask, ooh, well, what about these routes? What about when I'm hitting these other endpoints? Is there a meaningful difference between, if I'm working at a company that has like a free tier versus an enterprise tier? Is there like a meaningful differences between these tiers? And sometimes that's because I'm trying to assess how important this is and how much I should be like redirecting my energy and other people's work away from whatever they're doing to focus on this problem. Sometimes that's just me. I don't even know what this service talks to, and I need to get a sense for like how things interact with one another before I can really say that I've root caused what's happened. It's this very fuzzy space. And so I'm like, okay, well, given a bunch of data in a particular direction, I don't see why an AI assistant could not also assist with that and say, hey, well, if I'm trying to accomplish these three things, can I get pointed in a couple specific directions that are likely to lead me to either coming to a conclusion that something is happening, coming to a conclusion that something is not happening, or coming to a conclusion that I need to get more data? Um, that's a very, very important thing. And especially when you're in the context of an incident, the faster you can do that, the more valuable it is, because like there are a lot of companies out there that have SLAs that quite literally pay their customers for every second of downtime that they have. And so like you can actually measure the amount of time you're staring at graphs in terms of dollars, not just in your own paycheck, but like I've had customers who are like, yeah, we had an incident that cost the company $10 million. And they're like, yeah, the amount of time that we spend in an incident had better be as like small as possible before we're officially out. And in that constraint, like you want to be right, but it's this inherent like, several people who are working in the context of an incident just simply might not know what's going on. And so there's opportunities to suggest directions and help people come to conclusions faster. So anyways, I've been on that kick since late 2022 and helped build and ship some product at Honeycomb, sort of in very small service, I will say, towards that vision. And now I'm heading up our AI function at the company, and we help spin up our own dedicated AI team that kind of looks across the product for some of these, I'll call them like probabilistic opportunities, meaning some way that people want to do something using a part of our product. And it is a way that's like, there's no inherent one single correct answer. There's many possible directions that someone could go. And then saying, okay, cool. Are there ways that we can reduce the amount of time that it takes for someone to come into the product, get what they wanted, and get out of the product? That's sort of where I'm at right now as far as looking to use this tech.
Okay, cool. That's a lot to unpack there. That's a fantastic intro. So much there. So yeah, I guess when we think about observability, a lot of it, as you say, used to be, is the system up and running? Are there latencies? Now we're looking at from a developer perspective of tracing through an end-to-end from a system. I mean, I remember kind of doing this custom by hand years ago for a brokerage. A message comes in from the stock exchange. We need to trace this message all the way through to the UI when someone does a trade, and all the way back again, and all the timings and what went wrong. And then if someone says a trade took a long time, we'd have to troll through those logs and say, right, where in the system did it take a long time? Was it between when they clicked the button? How long did it take for it to go from the button click to the piece of code that handled the button click to the piece of code that serialized that, to the piece of code that sent that, to then being picked up on the other side of the wire, and then being, and so on and so on and so on. And so Honeycomb basically does a lot of that for you using this open standard, which is open telemetry. And then I guess the biggest thing that we've got here is the sheer volume of data. So we're talking about massive amounts of data. You've got all this numbers zip around the system, and then the time it takes to go from, oh, we think there's a problem, to what the problem is that kind of a factor of that amount of data, isn't it? So you've got people piling into Honeycomb, knowing we've got a problem, we are down. I've got to wade through the data to work out where it is. And kind of what you're looking at now really is, this is a whole of unstructured data. AI is good with unstructured data. And so if we put AI at the top of that, can it answer those questions really quickly? Can I go to the AI and say, where is it broken? And kind of get the answer. Horrible oversimplification, I know, on my part, but that's basically what it is, isn't it? You're thinking about OpenTelemetry is such a huge amount of unstructured data that you're capturing in logs and metrics, all that kind of stuff. You're considering, how do I apply the AI to that problem space? How can I enable those user journeys to be as quick as possible?
Yeah, and I would say that like each of those journeys ends up being very different for all of our customers because, as you might imagine, the quality and quantity of data that a given organization emits is just so variable from organization to organization, and the way that they sort of hop through their own architecture through a trace almost differs from developer to developer, like how they actually go about doing that. But I would say the common thread that everybody has is, where is the problem occurring? And can you give me a hint as to why? And that last part is often very interesting because it may not necessarily be evident in the data, because you may not have enough data that you've captured that tells you exactly why. But if it can narrow it down to like, well, in this mess of 500 services, there's this one service, and within that one service, there's really this one transaction. And there's this one thing that's like this name that's associated, and there's like this ID involved. It may not be like a correlation ID, but I'm talking about like within your application logic itself. You're like, hey, when like device ID ends up going through this workflow, it goes haywire. That is a very strong signal to like, okay, well, I might actually sort of know where in the code to look from now, and okay, I have this ID value. Great, I can pull that out. I'm going to run a test that like tests with that ID, and like it moves you forward a lot. And so in a sense, like one of the things that I'm starting to consider actually is like, given that like everybody needs to know where something is occurring, and people want to know why to whatever extent that they can, or at least sort of get hints that are helpful to them, is given this sort of developers starting to adopt observability tools a lot more, but at the same time, developers spending most of their day in the IDE and their collaboration tools like Slack, Teams, GitHub, so on and so forth, and VS Code or JetBrains or whatever they're doing. Is this an opportunity to pull information from, you can imagine there's Honeycomb or really observability backends. They are SaaS tools, but is it really the best forcing a developer to have to swap back and forth between their SaaS tool and the stuff they're actually spending all of their time in? I would argue not. I don't think that means the SaaS should go away necessarily. There's a lot of really valuable reasons to have a tool like that. But the pulling in where it happened and what are likely reasons why, and finding a way to map that back into your collaboration tools and your IDE, I see as probably being one of the largest opportunities in the observability market, because you can imagine you're a software engineer writing code, and like you never know when an incident is going to fire. So like you might, and there's varying severities of incidents and stuff like that. Something might be going on that might lead to some sort of catastrophic failure later. Wouldn't it be great if you got a little bit of a hint as to where in your code that sort of like hotspot was peaking up right now? And if you have a little bit of headspace to be like, oh, huh, wow, interesting. Maybe I should take a look at that. That could potentially be another interesting way to sort of surface this kind of stuff, and sort of like ultimately mapping back things that are happening in observability world to things that are happening in development world. Because I think at the end of the day, like software engineers want things to be oriented more around their developer workflows than to have their developer workflows interrupted by particular tools requiring them to sign in and look at a graph that is painted a certain way.
Interesting. Yeah, because so like pieces, for example, we focus a lot on that context switching idea that we want to have. You don't have to go to this application. We've got it inside the applications that you're in. Yeah, there is a Copilot in VS Code and JetBrains and your browser, and you're kind of, again, that same kind of idea of how do I surface this information where the developer is. So rather than developer have to context switch, and then as well, it sounds like you're thinking about a very proactive approach to this. So if you've got some AI job running, some agent running, because this is the year of the agent after all. You have an agent running that's looking at these patterns. Could you almost like surface that in a code lens? You're just in the code base and you get a notification. You go to it inside VS Code, and there's a function glowing red because your observability is saying that this is causing problems. Is that kind of the future that you're hoping for? This very proactive AI agent that's mining your data constantly and just throwing that straight at the engineers?
I would love for us to eventually get there. I would love for all development to all observability stuff to eventually move there. There's a lot of ground to cover, which I think we probably talked about quite a bit. The raw capabilities might be there. I'm not really sure. I mean, it bears experimentation, of course. But a lot of this is a data coherence problem, and some of this is just sort of fundamental to, like, you know, you have to have your code instrumented to some level of granularity for this to work. Otherwise, it ends up being sort of guesswork as to where in the code this is happening. And there's a little bit of movement in the open telemetry space right now around things like continuous profiling that are able to pull up, okay, well, we can correlate this trace that was slow. There was this profile that tells you, like, the function calls associated with that. I've found that even though in theory you may have sort of like, well-formed streams of data that are interconnected and even correlated by an ID, that does not mean that you can build an effective UX and effective system that sort of trawls through each of those streams particularly well. And you end up with a little bit of a mixed bag. I've seen this with people who, for example, they use Datadog, which is a great product. In their APM product, so Datadog is really a platform of many products, and one of their products is called APM. And in APM, you can look at your slow traces that are running through your systems, and then they have this thing called code hotspots, which, if you sort of lined everything up correctly, it works great. But if you've not, which is the majority use case, it kind of won't work. And like a lot of that is just like it's like, well, this runtime in this environment is unable to produce these kinds of profiles at this sampling rate within this time, and therefore it's a little hard to correlate these two things. And like AI can't really solve that one, I don't think. Maybe we'll have incredible profiling and tracing tools that are just 10 years from now so precise that this stops being a problem. But certainly today and over the next couple of years, we will very much run into that. And so then we're playing this game of estimating where in the code something is likely to be impacting what we're seeing. And I think AI tools can help with that, but then that implies a fundamentally different UX of, we're not going to act so sure about telling you that you need to put your eyes here. But we can give you several hints and say, we recommend these places based off of this criteria. You can choose to agree or disagree with that. And maybe you could say, oh, no, actually, the red herring, that criteria, I could see why you might think that that's important, but we're doing this really weird stuff in our code, and like that, only I know that, and blah, blah, blah. There's opportunities for that kind of engagement, I think. So like this is kind of where my head is at around pulling some of that stuff into these developer workflows, because I think it's better to be helpful and usually correct, but in a way that really allows people to redirect whatever the engine is sort of saying. Like I think we already see that a lot with ChatGPT and coding assistants, and certainly in the past. I think we see it less now, but in the past, people would be like, no, this is wrong for these reasons. Please do it this different way. And then like it can sort of get into this loop where it does another thing, but like it's in a slightly wrong way. And then you say, no, also not correct. Please do this. And then they sort of like come back to the thing that was wrong again. And you're like, okay, like you're spinning in circles here. Like that's kind of like one of these failure modes here. But like, we do want to encourage the nudging, but we don't want to build a system that accidentally nudges itself back to the bad spot where it shouldn't have been to begin with.
Yeah, because I have seen that a lot. As you say, it comes up with an answer. You say the answer's wrong, gives you another one. You say that's wrong. It just keeps flipping between the two. You end up starting a brand new conversation to try and remove the context, and yeah, it can be a real pain. I mean, you've obviously spoken a lot and written a lot about these different AI developer tools. So, how much can they help? I mean, if you spin up, say, Cursor, for example, and say, I want to support open telemetry in this application, is it going to do it? I mean, even if you just say, I need a function to do this, is it going to look at your code base and look at the fact that you're already got telemetry in there and put that in automatically? Because a lot of these LLMs are trained on code samples which don't have telemetry built in. So just thinking about an AI coding assistant, how does that help you even do the basis of telemetry, let alone do a good job of it? Do you find they're detrimental to the developer?
Yeah, that's a good question. And for what it's worth, this is something we're going to be experimenting with and releasing product around, or some. When I say releasing product, there's nuance to that. Sometimes the product is literally put this text file in your cursor rules, and it sort of works. So I'll describe for you some things that I know that work well. Modern LLMs like Claude 3.5 and 3.7, you should probably be using 3.7 these days, know about the OpenTelemetry API for all the different languages, and they know the basics of here's how you make sure that OpenTelemetry is actually wired up for your service. Make sure you're capturing a service name so it doesn't come out as a thing called unknown underscore service. Here's how you create a span for a function. This is what it means to sort of, you should be, if you're using Golang, you need to thread the context through and yada yada. But just because you can use an API doesn't mean you're actually using it well, because the effectiveness of OpenTelemetry is not a function of could you initialize the SDK and create a handful of spans. It's can you capture the right data where it needs to be captured? Sometimes that means you should be adding as attributes values to whatever the current span is, meaning it might be the root span actually for an entire service. So like one single span captures the entirety of the service, and just, the service may not be particularly large. So if you don't really care about other durations other than just how long it takes to move from the beginning to the end of the service, just throw everything onto that single span. It's a lot less data. Most because under the covers, like especially with OpenTelemetry, most of these systems use sort of this event-based model where every metric is an event, every span is an event, or like a structured log type deal. Every log is an event. Like there's sort of this breakdown where like everything is this thing that is called an event. And a general rule of thumb is if you have more of those events, you're probably going to be paying more money for that. It also creates a little bit more overhead on the service that you have to buffer these things and send them off asynchronously. And like every time you send a given event, there's a chance it could go wrong. There's retries, and like if you can get away with creating less data in the first place, or like less individual events, you're likely going to be better off. But finding that right balance of when do you create a new one versus when do you add to whatever the current existing running thing is a bit of an art and a bit of a science. And what might be the right decisions you make for one service may not be the right decisions for the other service. And there's a couple, whenever we work with customers, there's a couple questions we ask them around how important certain things are to capture, and how much work a given service is doing in the course of a specific transaction that occurs through your system. And you get a lot of varying answers. And if you don't have that data, it's really hard to get the LLM to do some of this for you, because it'll emit some code, but like, is that instrumentation code going to be better than if you had no instrumentation? Probably. Is it going to be better than if you had someone spend 30 minutes adding some log lines? Maybe not. And like you might spend a lot more than 30 minutes like farting around with trying to get it to do the thing that you want than you would if you went and added that stuff yourself. So like it's a bit of a mixed bag there. Something that I've seen that it does work very, very well with is if you have an older service that has some existing logs and you are anything but proud of those logs. These are horribly done. There's a lot of console logging going on. You're not using log levels. There's no structuring in any of this shit. Like, are you actually capturing things that matter? Absolutely not. It's just spew. A lot of people are in that situation because it was something that was kind of helpful, usually because some developer didn't know how to use a debugger, so they're just throwing out console log stuff, and like there's a time and space for that, but you end up with a lot of garbage. and it's really hard to clean it up after the fact, especially when it's something that is now this business critical service that's legacy code doing all this important stuff, and you're like, well, if you touch it the wrong way, like it might be a problem, right? There's a lot of opportunity in that space. Turns out, don't even transform the telemetry. Just take those existing logs, and you just have a small rule set that you can pass into Cursor, where you can say, use proper log levels, use the most common structured logging library that exists for this language. Boring as shit, like log4j. Great. Have it emit JSON. Replace the console log lines with the appropriate debugger info logs based off of what you think it should be. And the vast majority, because like you're starting from a place where your logs are noisy, garbage, terrible. You're going to move to a place where like 10% of that is still true. The other 90% is like actually probably okay now. You can also then say, oh, and while you're at it, when a function looks like it's doing something meaningful, capture the parameters that are the input to that thing into the log line itself. And just a very small handful of these things, and it's shocking how much better those logs get through just sort of like one pass through a code base. Now, it's the definition of those rules. There's some generic ones that you can write, and then there's often a little bit of non-generic ones that you have to sort of work, like an organization has to actually supply what some of that stuff is. But I would say the coding assistants are very good for that line of work today.
Right. So if you've got that situation, as you say, you've got the existing service, you don't want to rewrite it because you can't, it's legacy, it's in production. You just want to almost do a smart find and replace of console.write line with debugger library dot log info, something like that. It's great for those situations. It's great when it's got that context of here's the code base, just take that. But the problem you say arises because these LMs don't understand your business context. They don't understand what you know. They just understand a piece of code. So if you say, go forth and log this new code that I'm writing, it might just end up emitting a whole lot of events. And was it Honeycomb, for example, you charge by the event, don't you? So if it starts emitting all these events, it could get very, very expensive for you. And all you're doing is just putting noise into the system that you don't necessarily care about.
Exactly, and that's partly why. So observability is it's a great place to have. Like we talk about this later, where I think there's an enormous potential for observability in this world of AI in the future. But it's a very complicated space because every organization has different constraints compared to the next that are going to govern the way that they do their observability. Your constraints around cost. Even if you narrow this only to cost, say, oh, well, some people have a larger budget for observability than others, or like a larger relative budget compared to whatever their budget sort of is. Some people are like, yeah, we're happy if it's 0.5% of our overall spend. Some people are happy if it's 3%. Some people are happy if it's 0.0001%. And that ends up, on the lower end, you end up just unable to sort of capture the information that you actually need that folks like Honeycomb and Datadog as well sort of just say, yeah, well, maybe we're not the product for you. But I think increasingly as costs ultimately coming down, a lot of people are able to get more data in as a whole. But then you start getting into like, what is the meaningful stuff to capture? And this almost necessarily has to be a direct conversation with the people who you're talking to, because it will usually not be evident in the code. There are very often no like documents that you could feed in. Like some Acme Corp has this internal document that says this is the important stuff that this service does, and this is what's really important about the stuff that's captured. Blah blah blah. The chances that it even exists, let alone that it's accurate with respect to what exists today, is slim to none. And really, that context is sitting in people's heads. It's living in Slack and Teams conversations. It's living in temporary documents that are like not even in the standard document management thing, like some random person's gist file that they have in their organization that actually has the information about like the weird stuff that we're doing with Kafka right now, and like that you need to go look there, and golly, we swear we're going to document that someday. But like your instrumentation does need to know about a certain amount of that stuff for it to be effective. And not all of it necessarily, and there's different starting points, but like if you really want to sort of get to the zen of like, wow, like, we're no longer just chasing incidents, we're on top of how our services are doing and knowing about things before our customers really understand that there's a problem. um, that context is distributed everywhere, and so you have to be having a lot of these detailed conversations with people to like really narrow down what is the job to be done here. And there's an opportunity when you're working with them to then serialize that information. And we literally, we do that today. We've been doing that before AI, where like we produce like this document, like this shared document that's sort of like, the success plan for customer X, and here's all the stuff that really matters with respect to observability that like we have all arrived at because we banged our head against the wall to like really sort of make sure that this is captured. And then it's sort of left as an exercise to the rest of their development team to take that document and figure out a way to instrument towards whatever those goals are. And it almost always falls apart eventually, because you get some people who are really into it. Usually the team you're working directly with follows it to a T. Well, I shouldn't say usually, it kind of depends. But like once it gets out of the bounds of those people, it ends up being like number 2 on the priority list, then number 3, then number 4, then number 5, and so on. And then eventually you reach the point where nobody disagrees that this is a good thing to do, but because there's no organizational mandate, they don't ever prioritize it, and it becomes similar to like code quality updates. Like everybody's like, yeah, the code should be improved, we should do this like little refactor or whatever, but is it really important to the business? No. The only person who's going to do that is someone who like they're told by their boss this needs to happen, or they just can't live with themselves unless they do it. And bless their hearts if they do that. But I feel like that in particular, that's the dynamic where a level of automation can help. And I have talked with several of our customers and several prospects as well, where they're like, hell yeah, if you can have an AI agent that like throws out pull requests from time to time that says, hey, I instrumented in this way, and like this is roughly what it's going to capture. They're like, please God, do that. That would be such an enormous time saver for us. And I'm like, cool. That feels like a really good use for this kind of stuff.
Yeah.
How we get there can be potentially a bit of a journey, but I think like if they see the long tail of work as being something that a bot can do rather than that they have to do, that sparks a little bit of joy in their eyes.
So it's almost like the GitHub Dependabot, isn't it? That's their monitoring your version dependencies, and you don't have to have a human doing that tech debt of every week. Is there a new version of this? Is there a security vulnerability found in this? You've got this tool that just does that. The same kind of idea. If you can come up with, I said, a rules file for Cursor that as someone's writing code, it's going, does this align with your team's documentation? Or that agent that does it automatically, as you say, automatically raises pull requests, or even does a pull request, part of a pull request review, automatically adds the, hey, did you know you've got a team document that says this? And so having that agent that knows that team side of it. But I think kind of the important part here really is that human AI thing. And this is something I've spoken about a lot on this podcast with previous guests. It's a big thing to me is this idea that AI is an assistant. We talk about GitHub Copilot being the co-pilot that sits there with you. You have to have the human there. And you're saying essentially the same thing, because the human has that understanding across collaboration tools, documentation, all that information. The human has that knowledge, understanding. And then from there, you get a document, and then that then gets fed to the AI. And so the AI is an assistant based off this agreement that you've got as humans around how you want to do this observability in everything that you do.
Yeah, absolutely. And I think like when I think about the observability piece of it, so this is kind of starting to get a little bit more into the further visiony type stuff. Is Well, okay, so like observability today, what you really want to do is you want to reach a point where you're on top of your services and you know when something is unhealthy before your customers recognize it. And it takes quite a bit of a journey to get there. Part of that journey is effectively instrumenting your code. And there's a handful of weirdos out there like me who get excited about that. The vast majority of engineers who I've spoken to see that as a tax that you have to pay to be able to get the thing that you actually want. And anytime I see something as this is the tax I have to pay to play, that's an opportunity to automate that people will want to use, and that people will say, great, this is what this stuff should be for. Um, I think we're starting to see a few people start to recognize that in particular domains, that AI assistants, instead of like helping you pay the tax, can also actually help you do the job that you want to do. An example that I use for myself is I have my own website. I actually built my own calorie tracker inside of it because I was like, screw it, why not? Like, I have AI assistants that can spit out a bunch of code. I don't know much about Next.js and Tailwind and that kind of stuff. And if I'm being perfectly honest, I really don't want to know a whole lot about it. I just know that like it can create good looking stuff and it's very functional and blah blah blah. So I'm like, cool. Well, I have a black box that can emit code for me. Can I drive this thing to do the thing that I really do want to accomplish? And the answer is I totally can. And I would say every once in a while it kind of goes off the rails and does something I think is dumb, but the majority of the time it actually is helping me do stuff. And the way that I'll use it is I'll sort of I'll have a little rule file in there for, I use Windsurf instead of Cursor, but it's effectively the same thing. Just I like the UX a little more. Um, but I sort of give it an instruction where I'm like, think carefully about what I'm telling you. Don't write code immediately, and please ask me for follow up questions if it seems like it's unclear what I want you to do. And fairly frequently, it'll say, what you're asking for, well, I read, these files, and I know a little bit of context about this thing going on here. Really not clear about what you want me to do. Like, should I use this or this? And or this other thing, or like, what is it you're actually looking for here? And sometimes it catches me and I'm like, oh yeah, that this particular graph component that I'm trying to get you to build, I was a little bit unclear about what I would like the behavior to be. So yeah, thanks, like blah blah blah, type this in, and then it's able to sort of emit the code there. And that's when it's a lot more helpful, almost sort of like the writing the code part, which I derive zero joy from Next.js and Tailwind, so like it does that for me. And it is able to usually catch when I'm being too ambiguous about something, such that when it actually does emit the code, it is, I believe, much more likely to emit the code that does what I actually want it to do, as opposed to getting into this crap loop of the code doesn't quite work, and then you say it doesn't work, and then it tries a different thing, and then eventually it circles all the way back to the thing that didn't work in the first place. And now I've wasted 30 minutes of my life that I really wish I wasn't spending.
But do you find, though, the amount of effort you have to put into prompting it right is less than the amount of effort it would have taken you to write the thing in the first place? I mean, I guess with, like as you say, Next.js, Tailwind, you have no interest in really becoming an expert in that. So in these languages, English is the best programming language for you because you can prompt it. But if it was a language you were much more knowledgeable about, do you feel you'd have to spend more time prompting than you would just writing code?
I think I would spend more time prompting if I was working in an area that had particularly difficult constraints, or like subtle constraints, maybe not necessarily difficult. So, to give you an example, Honeycomb has this way that you can query your data. It amounts to what is basically a query language. There's actually an interface you can click around on with completion lists and stuff like that. So, it's nicer to use. But one slice of what you do is this thing called a calculated field. And that itself is its own domain specific language that has a set of functions that are available to you that work in a particular way, whether they emit true or false or a number, or you can convert strings and stuff like that. A while ago, I added the toLower function that converts a string to just full lowercase, because it's often very helpful for the purposes of comparisons, as you might imagine. You're trying to compare the value of an attribute to another value of another attribute inside of a query. And if you toLower them, that's just a hell of a lot easier to express. I used the AI assistant to help me with writing that. And so what I did is I first asked it, because we have a very large code base. I said, can you what are the top areas in the code that I will have to touch to be able to build this? And then it gave me a list of that. The list actually seemed plausible. There were a handful in there that were not correct, but it was pretty easy for me to sort of see why. And it did actually give me the complete list of files that I was going to have to actually touch, which was great. This is before Cursor was really good enough. I think it might be able to do the same thing. And then it found sort of like the core logic of like the actual implementation of the toLower code. Great. We use the Go standard library on our backend. Standard library has a function called toLower on strings. Seems pretty reasonable to me. I'm going to wire that up, and there's a bit more complicated stuff to, like how the string that you want to do sort of ultimately makes it to this function, and it largely did that. Um, and then I got a red X on the code review from one of our principal engineers saying, please do not do this. This is going to allocate like wild. And like, this is on a hot path. And, big link. This link took me to a document of like all the complicated ways that this DSL ends up being on a really nasty performance critical hard path for some customers in the way that they hammer our systems in a particular way. And like this is like literally caused incidents before, and like it's just this subtle area of the code base where like a lot of the code is not doing custom things, but every once in a while there's a function in there that's like doing what you would think the core library for Go is doing, but it's actually doing it in a slightly different way because it has to be done that way. Otherwise it's going to unnecessarily allocate more strings or do whatever. And I just happened to walk into one of those things, and I guarantee you that if I did not spend the time then thinking about what I need to really do here, and I just sort of said, hey, AI, like, they said this was bad. What should we do about it? I would just be off on one of those death loops for quite a bit. It would emit code that probably seemed plausible. Again, the principal software engineer would look at that and be like, this is bad. No. And like he would probably get mad at me and be like, why are you doing this? It's that act in particular of where it's hard to use pattern matching on what you see around you to assess, like, should you write something that's a little bit more similar or something that's very different, because there's this sort of like unstated constraint in the code, and those are all over the place in various services out there. And I think it's also a challenge because most software engineers who are working in those codes, those parts of the systems, are also not aware of those constraints in the first place. So and like, hell, the person working for the company that is nominally responsible for the code doesn't know about these things. How on earth is this language model supposed to know about these things? And that's where like there's going to be a very, very long tail of, you can't really prompt your way out of this thing, in my opinion, not without having enough expert understanding of what you do. And then like the time that it takes for you to prompt it effectively compared to writing yourself is it's equivalent. So you might as well, like, well, I don't know, I guess if it's equivalent you could do either, but like you're spending that time one way or another.
Yes, I guess in this particular situation, you need to make something lowercase. Yeah, the obvious thing is the standard library too low is what's going to do it. But yeah, the constraint is when you do that, you're allocating another string, completely copying things over. And there's no way the AI is going to know that unless you had some kind of performance unit test built in that would fail. And then, yeah, because 99.99999% of the situations, too lower works. But just when you're doing it a billion times, you cannot allocate a billion new strings that performance it is. So it's those, when you hit those edge cases, that's when AI falls down. I guess that's one of the worries that I have when you see companies like Meta saying, we're going to get rid of all of our mid-level engineers. It's like, well, how are engineers going to build the skills they need to know when the AI is getting it wrong? Like you're saying, there's a very, very senior engineers looking at your code saying, we can't do this. And this is why, because of very low level system constraints. If you don't have those very, very senior engineers because you just have junior engineers and AI, you're never going to hit those things. And every product's going to turn into something terrible.
Yeah, absolutely. And I think like this is where I've written about this. You kind of mentioned it at the beginning, how I believe uh, LLMs and AI right now are sort of like, we're seeing like the reintroduction of the computer, but in a fundamentally different way and different abstraction levels. Um, I wasn't around in the 1970s, but I would imagine that when it came out, it was pretty incredible what some of those raw capabilities were. And there was probably a fair bit of people being like, oh, all of this type of work that we do today is just going to be 100% automated. The computer's going to do it all. And eventually we found that it'll do a lot of things. A lot of the rote mechanical work, that gets automated. But the what that actually means is that gives you the opportunity to spend a lot more time on assembling the things that it can automate in a way that is valuable, and it ends up almost sort of like creating more work, but like that is like the more of the work that you ultimately do want to be doing. You don't want to be by hand calculating all the values in the spreadsheet. You want to be getting more spreadsheets that can be calculated. And using that analogy, I think, if we, this obviously doesn't exist today yet, but if future coding model comes out, we have black box that always emits perfect syntactically correct code that always uses the right APIs, always pulls in the right packages for the job, all that kind of stuff. Like, it will always be semantically and syntactically correct. It will always build. It will, all that kind of stuff. That's great, but that says nothing about, is it actually doing the job that you need to do under the constraints that need to exist in your system as it exists today. Full stop. And this has always been something that's really hard in software development is, do I understand my constraints? Do I understand what matters for my users in the business versus what actually does not? And it's fine if it's not implemented in the most correct way. And can I explain with the appropriate amount of detail what needs to actually happen here? What problem is that solving? And on the other end of that, how do I know I'm actually solving the problem? Like, how do I know concretely, like tests passed? Clearly not, right? I guess it kind of depends. If you can capture the entirety of every possible interaction with a given module in your unit test, if they all pass, maybe. But I would argue even that is probably not true, because the real test is still your users are using it, and do they like it or not? But that notion of is this doing the job that it should be doing, especially for complicated, the complicated software systems that run the modern world, that's forever shifting, because people's expectations are always shifting. You could no greater example of this than I think AI services, right? When ChatGPT came out, everybody was blown away by, you can do this with it now. And very quickly our expectations shifted, and we expected more and different things that current flavor of model was actually not really capable of doing anymore. And so you then ask, okay, well, how did the OpenAI people know what those capabilities are? Because if they don't know what people are expecting and what missing capabilities are, not allowing them to do what users want, then they don't have a direction to actually build better models and write better code. We face this exact same problem in software engineering. And so I sort of think ultimately we're going to arrive at a world where the computer, it also extends to the code writing and even the testing and the writing of the tests and all of that. And really our jobs are going to be, we need to understand the nature of the problem that needs to be solved and what its constraints are. We may even use an AI assist to sort of help us really sort of elucidate this correctly, and understand how we know we're solving a problem and what the problems that were being solved, and are they still being solved, are they irrelevant, that kind of stuff, and sort of have this the inputs and outputs to the ultimate system in the SDLC. We need all of that to be able to do more, because now if we can instantly have all the code that we ever want written in the entire world, we're spending less time in the code writing part. Great, fantastic. That doesn't automatically make everything else faster or better, because I would say what people really want is, they don't want more code, they want more working software. And that is a much larger thing to be tackled. And I think, the coding assistance part is great, but in a sense that's just a very mechanical piece to the larger picture of, do I know what needs to be done? Do I know I'm actually doing that? And how do I systemize that? And how do I get my humans to spend a lot more time on that stuff than spending time on JavaScript package update garbage bullshit?
Yeah, a phrase I like to use is, software engineering is the art of creating value for users, sometimes by writing code. And I think that applies here. And I was interviewing Shunde Person from Netflix for this, and she was saying that she only spends maybe 25% of her day writing code. The rest of it is all those things that you have to have as a human with humans to know what it is, the code that you need to do. And I guess your viewpoint is exactly the same. All the AI is going to do is minimize that code writing piece potentially, or mean we are creating a lot more code in that same time span, as there's increased expectations of what we can deliver. But we still have to focus on that human side. And although AI can boost that, it can support that. That's still fundamentally most important. It's not about writing code. It's, do we actually know what code we need to write? Do we understand our users well enough to do this? Brilliant. I think this is a great point to wrap up on. Thank you so much for your time today, Philip. It's been absolutely cool hanging out with you. It's been a long time since I've I saw you where we used to, for the benefit of those listening, we used to dabbled in F sharp together. So Philip was doing a lot of the F sharp stuff, and I was doing some advocacy for F sharp. It's been really cool to have you back on the show. So thank you very much for your time.
Yeah, likewise. Thanks for having me. It was great.